Hello and welcome everyone. In this chapters, we are going to see the demo for EIGRP. So first of all, we will see the basics of EIGRP demo, and later on we will see the master topology as well for EIGRP. So just for a recap, let's try and understand the IP addressing here. So as we have already done this, IP address configuration here. So just a quick revision for that. So this is my router 1 and this is my router 2 here, and router 1 has the fast Ethernet 0 by 0 where the connected IP address range is this 192.168.1.0/24, and then you have the 192.168.2.0 range is connected to my router 2 fast Ethernet 0 by 0 LAN, in which 1.100 is the IP address. Here 2.100 is the IP address for the interfaces, and later on the PC IP addresses like 1.1, 1.2 and 1.3, and the default gateway is 1.100. Similarly, you have the 2.1, 2.2 and 2.3 here, and the default gateway is 2.100 which is connected. Now between the routers we have the serial 0 by 0 by 0 and 0 by 0 by 0 here, and the network ID which we are using here is 10.0.0.0/8. This is a network ID, and from this network ID the IP address which we have configured on this interface, that is 10.0.0.1, and here you have the 10.0.0.2. This is my complete topology, and just to update, in this topology when it comes to complete IP address point, complete IP addressing is done in this topology already, as we have done in our basic one. Now see, here IP addresses has been configured in this, and also between the routers the IP addresses are already configured. That means we just need to go ahead and configure the routing protocols just to verify the same. What do you do now? I will go ahead and check it out. I will go to this one of the PC and I will consider this as destination. So I will do the ping from here to here 2.3, so that if you do the ping from here to here without configuring routing protocols, of course you will not have any kind of communications. Destination host unreachable you will find. Let us cross check and verify, and then we will do the routing protocol configuration and further verifications as well. Say this. So click on this router, PC, go to command prompt and do ping 192.168.2.3. see the IP address of your destination, it's 2.3. see here, correct? Now hit enter. Destination host unreachable, correct? Your PC1 cannot communicate with that. Similarly, you have the PC5, you go ahead and try to communicate with any of the PCs which is in this. Let us try and communicate. See, I will go to this command prompt and then say ping to 192.168.1. let's say 2. 1.2 is about your PC1. Fine. Say this. No communication, destination host unreachable. So why this no communication? Because they all into the one router's LAN, they all into another router's LAN. Of course, you require the routing protocol in this. So let's move ahead and do the routing protocol configurations. So we'll configure the EIGRP in this router, of course, yes. So when you want to configure the EIGRP in the routers, of course, you need to know some of the configurations command. If you remember, the configuration commands was very simple. It was like you need to make sure the IP routing should be enabled. Of course, that is enabled. Then you need to run the command which is routers EIGRP, then AS number, some AS number, let's say 100. I will configure both the routers into the same AS number. AS number is 100. The next command will be network, and then network ID. You need to provide the network ID, and then you need to provide the wildcard mask. Wildcard mask. And you need to perform this particular network command for each your serial as well as your Ethernet, fast Ethernet, both. That's it. This configurations you need to perform in both the routers. Once you configure this, of course, you are good to go ahead and have the communication as well. First of all, what is this wildcard mask? Is a very common thing. What is wildcard mask now? Let us try and understand what is wildcard mask, and then we will come back and configure it. Say this. So very first points to remember as of now. Say for example, we have a subnet mask of, let's say we have a subnet mask of /24. We have a subnet mask for /8 as well. Correct, no? Let me do one thing. Let's make it /8 and then /16 and then /24. This is what the different type of subnet mask you can consider, slash notations. If I want to write down the subnet mask for this in decimal format, it will be 255.0.0.0. For this, it will be 255.255.0.0. Hope you remember this concept since we discussed this in basics of IP addressing. This is what the default subnet mask. This is what my default subnet mask. If I want to calculate the wildcard mask, make sure if you want to calculate the wildcard mask, this is basically your opposite to subnet mask. Opposite to subnet mask. For example, if you have subnet mask as 255.0.0.0, you know what you need to do? Basically, you need to go ahead and subtract from the global subnet mask. What is the global subnet mask? See, global subnet mask is all about this global broadcast 255.255.255.255. This is my global subnet mask, global broadcast, correct? So you need to subscript. So 255.0.0.0. Now tell me what happens here if you subscribe minus. This will be, of course, it will be 255. This will be also 255. This will be also 255, and this will be 0. And this value now will be considered as your wildcard mask. So inverse of subnet mask, opposite to subnet mask is nothing but your wildcard mask. So if I say what is the wildcard mask for my one of the network here for this, so it will be 0.255.255.255. Similarly, if I want to calculate for /16, so what should I do now? Of course, yes, write down first your global subnet mask like this, and then /16 in the sense 255.255.0.0. So it will be 0.0.255.255. This will be wildcard mask for your /16. Similarly, if I want to calculate for this, then it is all about 255, fine, and 255.255.0. So wildcard mask will be 0.0.255. That's it, opposite to subnet mask. So make sure wildcard mask is inverse of your subnet mask, opposite to subnet mask. To calculate the same, you need to subscribe this from the global subnet mask. That's it. Let's come back to our configuration now. Hope you got the concept of wildcard mask. Let's move ahead. Say this. So since we know we cannot communicate from here to here, or any other PCs cannot communicate to these PCs. So how to have the communication now? So to configure the routing protocols, I'll go to this router and I will first of all check it out, the router's interface. Show IP interface brief is the command to verify the router's interfaces now. So it is here. See, as you can see, 192.168.1.100 is configured to fast Ethernet 0x0, your LAN interface, and for WAN, this is what the IP address. For this router, check it out, enable show IP interface brief. You see 2.100 is configured on fast Ethernet and 10.2 is configured on serial interface here. So let's move ahead and configure the routing protocol now. I'll come back to this router 1 and I will do the configuration first. Show IP route. See, this 2.0 is not present in this routers. That's the main reason you are unable to communicate. So what to do now? Go to next, configure terminal, router EIGRP, and then some number like let's say 100. AS number is 100. And then you will say network and then network ID. The connected network for this router is your fast Ethernet and your serial. So first of all, let's say 192.168.1.0 is the connected network ID for my fast Ethernet 0x0. Make sure you doesn't need to write the IP address. You need to write the network ID for the same. And then wildcard mask. So wildcard mask, it is basically your class C where we have kept this is as /24. So wildcard mask will be this 0.0.0.255. Done. One more network we have 10.network 10.0.0.0 and it is /8. So the wildcard mask will be 0.255.255.255. That's it. Exit. This is what my configurations of EIGRP in this router. Very simple. Make sure still when you go ahead and verify show IP route, of course there is no update to neighbor router because neighbor router is still operating with normal. There is no routing protocol in this. So what to do now? I'll go to this router now and configure the routing here as well. Configure terminal, router EIGRP, AS number should be same. AS number should be same. Then network, one of the connected network is this and wildcard mask as it is /24. So wildcard mask will be this. Next network you have this which is connected to my serial and wildcard mask / it is 20/8. So it is going to be this. Hit enter. This is your EIGRP configuration. See this, the moment we have configured this network, see, means your EIGRP neighbor is up, new adjacency. Adjacency in the sense, new neighbor. Now, if I verify here, show IP EIGRP neighbor, definitely you will be able to see there is one neighbor in this router. Can you see here? This is my neighbor 10.0.0.1. This router has the IP address of 10.0.0.1 where it is saying this is my neighbor and this is connected with this interface. Fine. What are these other things? This is your hold down. This is uptime, like how long, since how long this router is neighbor. Apart from that, these values are not recommended up to the CCNA level. Forget about that. So this is my neighbor table. Then show IP EIGRP, or you can directly verify show IP route. Can you see in this 192.168 which is connected to router 1, it is showing in my routing table and it is showing as a D. D is equal to EIGRP. See here, D is equal to EIGRP. Make sure this is your EIGRP update and this is your administrative distance and this is metric, composite metric. Similarly, if I get back to router 1, see in this router 1, I will be able to see this 2.0 network here. Verify. Show IP route. Show IP route. See this. D and 2.0 is present here, administrative distance, and the metric is also present. That's it. So this is basically your EIGRP configuration and verification. Check it out whether the communication is possible or not. Let's move ahead. So in this, now I'll go to this and try to ping the same PC. Definitely you should be getting the response here. You see that? Of course, yes, we are getting the response here. Similarly, you go to this PC and try to communicate with the same. See this 1.2 means PC1. Definitely you will get the response here. The first packet will be dropped maybe due to ARP request and response, and second packet onwards the communication is happening. Correct? If you try to communicate with 1.1 also, definitely you will get the response C. So that's it for this particular lecture, folks, and we have discussed about EIGRP configurations in our basic topology. Advanced topology we will see later on in this series. Thank you. See you in the next.